Good morning, gentlemen. This is the next experiment that we are going to do, which is electrical resistivity. In the manual, it is experiment number 4. These are the very simple experiment and easy one. These are the devices that we are using. We are going to use a vernier caliper. The name of the device is, instrument is vernier caliper, and also a digital voltmeter and a small pencil. So what we have to do is we are going to measure the resistivity of the graphite using a pencil. You can see here both ends are open. We have a graphite inside. So what we do, just to switch on the digital voltmeter, we can measure the resistance by using the two probes. Touch the two end of this pencil, two end open pencil. Normally you won't see that. Then you can measure the resistance over here. So and just tabulate the value. After calculating the resistance, tabulate the value in the table. You can see here L, D and R. R is the resistance, rho is the resistivity. Resistivity, we can measure it from this formula, and to measure the L and D, we are using the vernier caliper. Use a vernier caliper. Keep the pencil between the two jars. Keep the pencil between two jars and find the value of L. At the same time, you can measure the diameter of this one. How? I'll show it very clearly. I'll show it clearly for this one. You can see here this way. You hold it like this, you hold it like this, and then measure the diameter. This is the ruler over here, scale that you are going to measure in this one, and find the diameter of the graphite. Not like this one, this is wrong. Actually this is for the wood, and this one is for the graphite material. This is for the graphite material. And after measure just take one data and fill it here, length and the diameter and resistance using the digital voltmeter, and finally rho using this formula. After that, we have to do the second part for finding the thickness of the shaded portion. To do that, take a graph sheet, shade like this with a small pencil, shade a small shape, shade it in the same way. That's small, but which the distance between these two terminals are 1 centimeter, which is 10 millimeter, and it can go up to 200 millimeter. Why we have done so? Because that's a value that we are going to do. L is equal for 20, 40, 60, and it will go up to 200. Each place we have to measure the value of resistance. How to measure the resistance? Again, use a two probe. Put one probe here. This is 0. And put another probe here, this place, which is 20. Why it is 20? From here to here it is 10, and then up to here it is 20. And then don't move the other probe, but just move the second one. Put it in 40. When you put your probe on these 2 points, you are able to find a resistance. Because of the graphite material, you are able to observe a little amount of resistance over here that you can measure it from the digital voltmeter or DVM, digital multimeter. And then keep on doing, just to change the position of the second probe. Put it for initially we started from 20, and then 40, 60, 80, 100, go up to 200. Each time measure the value of resistance, because the graphite is a good conductor, so it will give some resistance. After that, you draw the graph between R versus L. R value is here, L value is here, and then using this value calculate the value of thickness. Thickness value is here. Then you will get more information through your teachers, experimental teachers, while you are while you are in the lectures. We have to find the value of the thickness T on the shaded position. That is the second objective. First objective is calculate the resistivity and resistance, and the second one is the measure the thickness of the shaded portion on the graph sheet. Thank you and good luck.